Hey guys, welcome back to another video. So this is again another summary session that we have on OOP. But before we begin, just a quick note. This session does not include any interview questions. That's because object-oriented programming isn't something you just memorize for interview. It's a core programming philosophy, a mindset that helps you to build scalable and maintainable code. So in this video, we are focusing on helping you to understand the concepts, how classes and objects work, how inheritance and encapsulation make your code cleaner, and how real world logic translate into Python codes. Okay. So once you have that clarity, your interview becomes easy because you're not just recalling answers. You are trying to think like a creator and you have your core principles strongly built. All right. Let's dive into today's summary session and see what we have for today. So first one is object-oriented programming. So object-oriented programming, or OOPS, is a fundamental concept in Python that allows us to structure code in a way that mirrors real-world entities. Okay, and object is data plus behavior. So we've built our programs around objects which represent data and action that can be performed on that data, right? An object contains both data, we call them as attribute, and functions that act on that data, we call them as method. Okay, we create this object using classes. Think of classes as a blueprint, and the objects are the individual houses built upon that blueprint. All right, so a default syntax of class is class, you give a class name and followed by colon. Moving on, what are classes and objects? So let's understand how classes and object work here. So a class is defined using the class keyword, okay? Whereas objects are the instance of the classes, right? So when we create an object using the class, Python runs the special init method in itself, okay, which is also known as the constructor. Okay, so this method is used to initialize the object's attribute, setting a brand or a model to the car like we had seen. And inside the class, we use self to refer to the current instance of the object, which allows us to assign and access multiple or say unique values to each of the objects, right? So suppose we have 10 different objects. So these self will make sure that we point to the current instance of the object. Moving on, what are instance versus what are class attribute? Okay. So in Python, attributes can be defined in two levels. Okay, one is on the instance level and other one is on the class level. So instance attribute are specific to each object. For example, if you create a car, the car object may have its own color or brand. So class attribute, on the other hand, is shared by all the instances of the class. So when you say the manufacturer here is what we have given as pseudo motors. So this is shared across all the instances. Whereas the brand or the color is going to be specific to that particular specific object itself, right? So what is the advantage of using a class attribute? So it would help you to manage your data efficiently without repetition. So each time when you create an object of car, say car 1 is equals to, you'll say car, and you will pass here, say the brand is BMW. Okay, so you don't have to pass the manufacturer each and every time. It's already there with the class, you just have to use it. So we have instance versus class and static method. So by default in Python, we have three kind of methods. Okay, one is the instance, second is the class, and third is the static method. Okay, now instance method are most common. We had seen them, we had seen it here. So here, if you want to talk about instance method, init is one instance method. Similarly, if you want to have some other method, you will say define, and you will say speed. Okay, you will take self here and you will say speed. Okay, and similar code you will have inside your instance method. So this is going to be specific to all of your instance, that is not shared across any of the instance, right? So that is your instance method. It uses self to access the object and the data, right? The second one is the class method. We had used this using @class method decorator, and it is accessed via CLS. So class method can be declared with @class method decorator, and CLS is the first parameter here, if you see, right? So these method can access or modify class level attribute, right? Anything that is specific to the class level attribute. We had seen how we were calculating the number of objects that we had created, right? So if you are not sure of what we are talking about here, I'll give you a link in the I button. You can go there and check the video. Okay. All right. And then we have static methods. So static methods use @static method decorator, and they don't use self or CLS, right? So they behave like a regular function but inside a class. The reason for having them inside a class is for a logical grouping. They don't have to be called using the object instances. You can directly call them. But since they are logically belonging to a particular class, so it is grouped inside a class. Okay, and they use @static method. Okay. Again, I'll leave a link here to make sure that you, for if you are not aware of these two, you can go to the video and you can watch it and learn on how these works. Okay. Moving on, we have encapsulation. What is encapsulation? So it says restricts access to object internals. Okay. So encapsulation is a practice of restricting direct access to some of the components of your object. Okay. You don't want to expose everything to everyone. You are going to limit your exposure based on certain levels of access, right? So say in Python, it gives you 3 different access modifiers. They are public, protected, private, right? And they are defined using a naming convention. So a public uses just the variable name, a protected uses a prefixed underscore, and private uses 2 prefixed underscores. Okay. So a private attribute might not be accessible using the object. So you have to create a getter and you have to create a setter method for reading and writing a value to your private variables. So these getter setters are used to control the access to your private variable. So encapsulation helps in protecting the internal state and ensures the object maintain a valid state. Moving on, what is abstraction? What is abstraction? Abstraction is about hiding internal detail and showing only essential features of an object. Like you see here, it hides the complexity and exposes only the key features. So in Python, abstraction is commonly implemented using abstract base class with the ABC module. Abstract base class, which is ABC module. Okay, here ABC module. So by defining abstract methods using @abstract decorator, we force subclasses to implement them. Okay. If we have used a abstract class and if we have abstract method, so to implement a class, it's mandatory that your child class is implementing all of the methods inside your abstract class. Okay. It won't allow you to execute a program without having the implementation of your abstract methods. So this ensures a consistent interface across different implementation. And abstraction or abstract class or abstract methods is a very widely used concept when you are designing your frameworks or when you are developing a large application. So if you want to learn in detail, I have a separate video on object oriented programming. In fundamentals, I have talked about all of these. You can go and check that video. All right. Moving on to the next one, which is inheritance and super. So, what is inheritance? So, it enables reuse across classes. How it does? So, inheritance allows a class to reuse code from another class and helping us to follow DRY principle. Do not repeat yourself. What it does here is it allows you to create, or it allows you to inherit properties from your parent class. Okay, so anything that is defined in your parent class, you don't have to redefine it, you just have to inherit it. And by inheriting, what you are doing, you are absorbing all the methods that your parent class has. So if you see the example here, we have a electric car, and my car class is also having an electric class. Say I didn't had this here. Okay, and if I have to call just the start, so I'll just create an object of I'll inherit my car from here, and I would just directly call the start method. So what it would do, it would directly use the same start method and it would give me an output rather than rewriting the code here. Okay, but why have we rewritten the code here? We have rewritten the code here to demonstrate this super keyword. Okay, what happens when you are trying to access a method that is from your parent class, right? You have the same method. Say start is your car has the start method, your electric car also has a start method, but here you don't want to call, I mean, as soon as the electric car start is triggered, I want to trigger this method from my parent class. So what I'll do, I'll just say super dot star, which will go and call this particular method here. So to access the method or constructor of the parent class, we use super keyword. And then we have different levels or different type of inheritance in Python. We have single, we have multi-level, we have hierarchical, we have multiple. And then what is MRO? MRO is nothing but method resolution order. All right, so Python handles the complex inheritance path using MRO, which ensures a predictable behavior when multiple base classes are involved. So there are two or more classes which are being implemented in your base class, okay, in your child class, right? So you have A as a class, you have B as a class, you have C that is using both A and B. Now, when you are trying to access the methods from A and B, how is that going to be accessed, or what is the pattern that it's going to follow? Is the how is the class going to understand which method or which class I have to target? So all of those things are being taken care in the MRO function or the MRO order. So we have, if you want to understand, you can pass the name and then you can give dot MRO, or there is another function called underscore underscore MRO. Okay, so these both will give you the order of how the object is accessed. Okay, then moving on to the next one, we have polymorphism and duck typing. What is polymorphism? We have talked about this. Poly is many and morphism is multiple copies. So polymorphism, morph is copies. So polymorphism is multiple copies. All right. So what it says is it's the same method name but different implementation across classes. Okay? So it enables the object of different classes to respond to the same method in different ways. So if you see here, we have a petrol car class, we have an electric car class. Now both of these have their own start method. So if you understand polymorphism concepts, you will see here that both the function have the same start name, I mean the same start method, but how I'm going to implement or what I'm going to do inside my method is up to me. Okay, I'll have a different start procedure for my petrol car. I will have a different start procedure for my electric car. So this is possible using polymorphism concepts. And what is duck typing here? Let's go by the saying, if it looks like a duck, if it quacks like a duck, it's treated like a duck. Okay, so as long as the object implements the required method, it can be used without its class type. Okay, so if you see in this example, I have two classes which have start implemented inside it. Then I defined a method outside the class, and I'll say this method takes an input which is car, or takes a argument that is car. And what I'm doing, I'm just calling car.start. So car.start means car I am referring to as a class here. Okay. So I'm saying class name which has the start method can be called using this. So while I'm calling, what I'm doing here is I am just saying start car. I'm calling this function here, or the it's a function here. I'm calling this function here and just saying petrol car. I'm passing petrol car here. So this petrol car goes to this car variable, and then it says petrol car dot start. So it starts the petrol car function, or it goes to the petrol car function. Similarly, when it's an electric car, so electric car is passed here, and it goes to the electric car class or the electric car start function. So it doesn't matter which class you are referring to until or unless you have this method available inside your class, it's going to implement your logic, or it's not going to fail. All right. So that is duck typing in your Python. It ignores what type of object or what type of variable you are passing, but only thing is, if the object implements the required method, it can be used without worrying about its class type. Okay. Moving on. So we have Dunder methods. So Dunder methods or double underscore methods lets us define how our custom objects behave while in a class. Okay. So let's say you have a class, you have multiple objects inside it, you have multiple comparison, you are doing multiple things inside your class. So you are comparing something, you are doing an addition, you are just trying to print the class. So while you do that, you will just have the basic version of your class doing that. So once you say, like, you just want to print the class, like we had seen in the example, you just want to print the class, you will just get a class reference. Whereas once you define the str method here and you try to print the class, it will give you a custom message that you have written here. So similarly, the other functions also, the double underscore functions or the method, they are very useful when you are trying to override the basic operations that those operators are doing. Say underscore underscore eq is the same as using the double equals. So if you want to do a change, or if you want to some add a comparison, or you want to add a logging message inside your framework level, saying that whenever I'm using a comparison operation, I want to print this in my log. So what you'll do, you will implement this underscore underscore eq as def underscore underscore eqs and self here. Instead of str, you'll use self here, and you will just add a print statement also. Okay. You'll say, I want to print the comparison result. You'll do a comparison, you will print. So you can override the actual behavior of those particular operators inside a class. Okay, so this is defined inside a class. The only advantage of using these Dunder methods are it makes our class more intuitive and more user friendly. Okay. Moving on. So we have come to object lifecycle. So we know init is the method that runs every time we create an object, and delete is by default executed by Python when we are deleting the object. So how do we understand that we are deleting an object? So Python uses reference counting and garbage collection. All right. So it creates, say you create an object and then that object is being referenced multiple places. So it will create a count of how many times the object is being referred to. As soon as the count is 0, Python will destroy that particular object. Okay. So Python handles memory management using reference counting and garbage collection. To add on, we don't usually have to manage memory manually. Okay. Python takes care of it internally. Like we gave a method here, say init method we had here. So we are defining what is supposed to happen inside init. Similarly, on your framework level, you can define what is supposed to happen inside your delete. Say you want to have some ramp down scripts. You want to close all your database. You want to close all the files that you have used. Okay. So this can be a place where you are going to write the code for all the ramp down, and init would be a place where you'll write your code for ramping up. So you are having a database connection starting here. You are going to open files here. All right. Having said that, once you want to open a file, you don't want to keep the file open throughout your session. You want to read it, you want to do the operations, close it, right? You don't want to have it open throughout your execution, right? So those things we'll see on the framework level. So these are the concepts that we have discussed, and we have gone through each of those examples. If you are not clear, go back to the previous videos, watch it, and again come back here. This video is just to summarize the concepts for someone who doesn't want to go through all of those concepts. Okay. All right, guys, that's all I wanted to talk in this video. I'll take the next few videos on the miscellaneous topics, or some topics that we have missed in the past or we have parked it for the last. And there are just a few topics left that I want to cover under the Python basics, and then we'll move on to Selenium. All right. Thanks for joining, guys. I'll see you in the next one. Bye bye.